In the murky, dark waters of Africa and South America, sight is almost useless. The world is a permanent twilight, a place of shadows and silt where predators hunt by feel and ambush. But what if you could defy the darkness? What if you evolved a superpower that lets you see, hunt, and even talk, using a force of nature itself? Well, some fish have done just that. They've harnessed the power of electricity. They generate invisible fields around their bodies, not to shock and stun like the famous electric eel, but for something far more sophisticated. They use it to build a 3D image of their world, find food, and send secret messages to one another. They have an electric language, a silent, invisible conversation that decides territory, attracts mates, and warns of danger. This isn't science fiction. This is the story of the fish that mastered the power of electricity, and their secret world is more complex than we ever thought possible. When we think of electric fish, we usually picture the powerhouse of the Amazon, the electric eel. That's a creature that can unleash a shocking jolt to stun its prey. And while we used to think that meant a few hundred volts, we now know some species can discharge up to 860 volts. But the fish we're talking about today are different. They are the weakly electric fish, and their superpower isn't about brute force, it's all about finesse. Living in perpetually dark and cloudy rivers, these fish faced an evolutionary problem. How do you get around in a world you can't see? Their solution was to generate a weak electric field around their bodies, using a special electric organ made of modified muscle or nerve cells. This creates an electrical bubble that extends about a body's length in every direction. Their skin is covered with thousands of hypersensitive electroreceptor cells that detect any disturbance in this field. An insect larva, a sunken log, an approaching predator, each one casts an electric shadow that the fish can perceive with incredible accuracy. This is electrolocation, a sixth sense that turns their entire body into a living 360-degree sonar system. This ability has evolved independently several times, but two of the most fascinating groups are the mormyrids of Africa, often called elephant-nose fish, for their distinct trunk-like chin, and the gymnotiforms of South America, or knifefish. Knifefish glide through the water with a long, undulating fin, holding their bodies rigid to keep their electric field stable. And while they both use electricity to see, the way they talk is where things get truly interesting. They've basically developed two distinct electric languages. The mormyrids of Africa speak in pulses. Their electric organ fires off short, distinct electrical discharges, or EODs. Think of it like a biological Morse code. The meaning isn't in the pulse itself, but in the timing and the quiet intervals between each zap. A short pause, a long pause, a rapid-fire burst, these are the words and sentences of their language. They can tell each other their species, sex, and social status. Amazingly, scientists have found that mormyrids use pauses in a way that's very similar to how humans use them for emphasis. Before sending an important signal, a mormyrid will go silent for a moment. This brief pause lets the listening fish's brain reset, making its neurons more responsive to the message about to come. It's the electrical version of taking a breath before you say something important. They can even hold a conversation by engaging in a kind of echo response, where one fish answers another's signal with a rapid, precisely timed reply, creating a synchronized back-and-forth dialogue. Meanwhile, across the Atlantic, the South American knifefish took a different path. Instead of pulses, most of them speak in waves. Their electric organ emits a continuous humming signal, almost like a radio station broadcasting on a specific frequency. They communicate by modulating this wave, changing its frequency or amplitude to create different signals. For knifefish, these modulations are their vocabulary. They use brief frequency spikes called chirps for social signaling. Some chirps are used to show submission, while others are part of an elaborate courtship dance. During mating season, a male knifefish might broadcast a strong, stable frequency that consumes up to a quarter of his total energy budget, all to prove his fitness to females. When a female is interested, a complex electric dialogue begins, with thousands of chirps exchanged to perfectly synchronize the release of eggs and sperm. So, if you have hundreds of fish in a river, all broadcasting their own electric signals, how does it not turn into total chaos? This is what scientists call the cocktail party problem. How do you listen to one conversation when dozens are happening all around you? Incredibly, these fish solved this millions of years ago with something called the jamming avoidance response, or JAR. When two wave-type knifefish with similar frequencies get too close, their electric fields interfere with each other, creating a beat pattern that scrambles their ability to electrolocate. It's like trying to see through a strobe light. To fix this, the fish with the slightly lower frequency will automatically lower its frequency even more, while the one with the higher frequency raises its own. They instantly and unconsciously shift their signals apart to keep their own channel clear. This is such a brilliant solution that it evolved independently in both African and South American fish, a stunning example of convergent evolution. For all its advantages, an electric field has one huge drawback. It screams, "I'm dinner," to any predator that can listen in. Electroreceptive predators like catfish and the powerful electric eel have evolved the ability to eavesdrop on these weak electric signals. They tune into the low-frequency parts of the signal, which travel farthest through water, making the weakly electric fish fatally easy to find. This kicked off an evolutionary arms race. To survive, the weakly electric fish had to invent a cloaking device. And they did. One group, the hypopomid knifefish, developed a truly ingenious trick. Up close, their electric field contains a wide range of frequencies they need to see. But as the signal travels away from their body, the waveform is structured in a way that the low-frequency parts, the ones predators hear, cancel themselves out. The result is a low-frequency bubble that exists only right next to the fish's skin. While at a distance, the signal is nearly invisible to predators. It's biological stealth technology. Some males can even turn this cloaking on and off, getting louder to attract a mate and quieter when they need to hide. We've talked about jamming from other fish and eavesdropping by predators. But what about the most obvious problem of all? How do these fish not constantly overwhelm their own senses with the electric pulses they're generating? How do they tell the difference between their own signal and a signal from the outside world? The answer is a remarkable neural mechanism called a corollary discharge. Every single time the fish's brain tells its electric organ to fire, it simultaneously sends a memo to self to its sensory system. This memo is an exact negative copy of the signal it's about to produce. When the real signal arrives at the receptors, the negative copy arrives at the same time and cancels it out perfectly. This makes the fish effectively blind to its own constant chatter, allowing it to be exquisitely sensitive to any external signal, like an insect or another fish. This noise cancellation is so critical that if it's interfered with, the fish can't properly sense their surroundings. Even more astonishingly, this system is adaptive. During breeding season, a surge in testosterone can cause a male mormarid's electric pulse to change shape. Researchers discovered that the corollary discharge signal in his brain changes right along with it. perfectly updating the cancellation filter so he can continue to distinguish his voice from others, even as his own voice is changing. This incredible evolutionary saga, a story of communication and senses, predators and prey, invisible languages and neural filters, is more than just a biological curiosity. The solutions these fish have engineered are inspiring a new wave of technology. The unique way their specialized electric cells generate power so efficiently has caught the attention of biomedical engineers. By understanding how these cells work, we might one day get ideas for designing biological generators to power medical implants like pacemakers. The neural circuits behind the jamming avoidance response and the corollary discharge also provide a fantastic roadmap for how a brain can process and filter signals. This knowledge could one day help improve the design of bionic implants and even sophisticated AI. These fish, hidden in the dark rivers of the world, may hold the keys to future innovations we are only just beginning to imagine. From the murky riverbeds of Africa and South America, an entire world of communication has been flourishing in total silence. Written in a language of electricity, it's a world of pulse conversations and waveform arguments, of jamming avoidance and predator cloaking, of brains that have perfected the art of filtering noise from reality. These fish didn't just adapt to the darkness, they conquered it, turning a force of nature into a sixth sense and a secret language. They are a profound reminder that even in the most challenging environments on Earth, life finds a way not just to survive, but to innovate in the most shocking ways imaginable. If you found this look into nature's hidden superpowers as fascinating as I did, be sure to subscribe and hit that notification bell, because there are always more strange and incredible stories waiting to be told. Thanks for watching.